Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
N is a sequence and real sequence. So one of our goals in sequences were to find the limit if it exists. N. Okay. What is the sequence of this? Like, what is the limit of this? AL. So now the goal is that we want to understand the idea of this summation of n or k from 1 to infinity ak. So we add up the sequence, like essentially we want to know what will be the a1 plus a2 plus a3 plus dot, 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 this infinity sum. And so this is the goal. So the question is that, so the natural question is this. So what we are trying to explore is this, that what are the conditions on an that will make this the good number? What are the conditions? So before, so what do we mean by good number? What is this trying to say? Like, is it a finite number? Is it infinity? Essentially, we have to define. So we have to define what is this, what we're trying to do. Define like summation of AK. What do we mean by this? What exactly do we mean by this? And that's where the definition of series comes in. And it tells you that, okay, it's same as series. So what you do is that you construct an alternative sequence. You call B1 is equal to A1. You call B2 is equal to A1 plus A2. We call B3 is equal to A1 plus A2 plus A3. And you call B4 is equal to A1 plus A2 plus A3 plus A4. And you continue like this. You call Bn is equal to A1 plus A2 plus A3 dot dot An. Now the question is that this is a new sequence. Question is that how does Bn behave? Whether Bn converges or not. So the question that we are going to ask is that, so these are called, so these Bn's, or you can also call it essence. This Bn is nothing but called the partial sums. You're taking partial sums of the sequence in. So partial sums, all for all n. So it's called a partial sum. We're trying to understand the partial sums and we have to see that how it behaves, whether it converges, it doesn't converge, what does it do? Okay. So our goal is to say, our goal by a good number, we mean that when will this Bn converge? Rather, you see that from An the Bn are produced, right? The partial sum. So the behavior of this Bn will depend on behavior of An, right? So the question is that what are the conditions? I'm again repeating. What are the conditions? What is the behavior on An that leads to the convergence of this partial sum sequence? Essentially, we are converting a series problem into a sequence problem, and we are seeing the underlying sequence ka behavior or properties, or how essentially how it's a sequence behaving to analyze the convergence of series. All of you understood the goal that we're trying to achieve here? This is a basic goal. All of you understood it? Yes or no? We're trying to find the, like, we first is that we try to convert sequence into series into a sequential format by partial sums. And we're trying to understand that what are the properties on those ANs that lead to the convergence of summation of A, like the series. Okay, because the series is entirely based on AN, right? So let's take some examples of series. So this is a very fundamental goal. Remember this goal. Let's take An is equal to n. So if you take the summation of An 1 through infinity, what it will be? Can someone tell me? Yep, infinity. Yeah, it's simple because if you take the partial sum, it will be n into n plus 1 by 2. So let's call this Bn, and this Bn you can see goes to infinity. Right? Right. Okay, so let's take An is equal to a smaller one. It's going to a smaller one. I'm taking a smaller, a lower kind of, it goes to n, so I'm just taking constant stuff. So if I now take ak is equal to a k from 1 to infinity, so Bn is equal to k from 1 to n, ak is equal to n, right? So you can also see here Bn goes to infinity, right? It's increasing. So let's do a smaller one even. Let's do An. So let's do the next one. An is equal to 1 by n. We are dividing, keep on dividing by n. And let's take Bn is equal to, we are interested in understanding summation of ak from 1 to infinity. So we define Bn to be summation of ak 1 to k from 1 to n. So we are getting it's 1 plus 2 half plus 1 by n, whether this converges to infinity or not, or this so it's like seems like, so let's see, let's explore. Of course, this is called harmonic series and this is divergent. This goes to infinity. We're gonna prove this. So the proof is very simple. There are many ways to prove this, but I will prove it in a different way, like basic. So observe that 1 is greater than 1, equal to 1. So half plus 1/3. So let's do this thing. 1 here. half plus one third is greater than equal to, let's think about it. Yeah. So all both of them are greater than equal to 1 by 4. So there are two of them. So both of them, let's say it's 2, 1 by 4 plus 1 by 4. It's 2 into 1 by 4. That is half. Now let's check 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7. Same thing. You take 4 times of 1 by 8. 4 times. So it's half again. So you can also do this greater than. If you take 1 by 8 plus 1 by 16. So 1 by 15. So there'll be all of them are greater than 1 by 16, and there are 8 of them. 8 to 15 are 8 numbers. So it's again half. You can keep on continuing like this, and you can say here on the left hand side, this is nothing but this summation of k from 1 to infinity and greater than. You can see. So let's do it mathematically a bit more. So what you can do is this. So you can see that 1 to the power 2 to the power I plus dot 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 1 to the power 2 to the power I plus 1 minus 1, right? You can see 1 by 8. So 8 till 8 minus 1. So there are how many numbers out there? There are 2 to the power. How many numbers out there? 2 to the power I plus 1 minus 1 minus 2 to the power I plus 1. How many numbers are there from A to B? A, B minus A plus 1. So this is B, this is A plus 1. So you can see that therefore from here that this turns out to be this plus 1 minus 1 will cancel, and this will be 2 to the power I plus 1 minus I into 2 minus 1, which is 1. So therefore 2 to the power I numbers are there, and each one of them is greater than or equal to 2 to the 1 by 2 to the power. So it's 2 to the power I by 2 to the power I plus 1. So it's half. So every set 2 to the power I numbers. So we divide the entire set, like it's 1, then 1 half, sorry, half, 1/3, then 1/4, 1/5, dot, 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 1/7, and it carries on like this. So every such thing is greater than equal to it. This is greater than half. This is greater than half. This is greater than half. So you can see that all of them, if you sum it up, the sum will be greater than. So till, if you take a partial sum till this point, summation of a k from 1 to 2 to the power n minus 1, it will be nothing but greater than, it's equal to what? It's equal to 1 plus half plus 1/3 plus dot 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 2 to the power n minus 1 dot 1 by 2 to the power n minus 1. Yeah, that's what the whole thing is. And this will be deal. So how many such brackets are there? This is first bracket, greater than half. Second bracket, so it's 2 to the power 0, that's the first bracket. This is greater than the first half. This is 2 to the power 1. I'm taking the starting point, okay? I'm counting how many brackets are there, 2 to the power n minus. So 2 to the power n minus 1 brackets, right? 2 to the power n minus 1 plus 1 brackets. So 2 to the power 1 for first bracket, then the next bracket starts from 1 by 4, which is 2 to the power 2. So therefore n brackets. This is the first bracket. This is a 2 to the power first bracket. This is 2 to the power 0th bracket. So this is the first bracket, second bracket, and here it's 2 to the power n minus 1. So it's nth bracket. So the n brackets out there. Okay, you can easily understand. So this is greater than equal to each greater than 1 by 2. So all of them are greater than n by 2. Now if you take the limit on both sides by Sandwich theorem, this is nothing but what? This is b to n minus 1, right? 2 to the power n greater than n by 2. Now assume that the b limit of b exists. We assume that because we know it's existing. So it's a monotonic sequence, right? Bn is a monotonic sequence increasing because every time a new positive number is added, it's 1 initially, then 1 plus half plus half, then 1 plus half plus 1. It's like positive numbers. It's a monotonic sequence. So either it is going to infinity or it is going to a constant number. So now therefore either the limit, so I'm assuming that I'm coming to your doubt, Swati. Now I'm assuming that the limit exists, and if the limit exists, say let's take the limit L n tends to infinity, and this will go to infinity. So this is L, so L is greater than infinity. So so L must be equal to, the only limit possible is infinity. We'll come to this point. It's called comparison test. We'll come to this point, but this is the basic idea. Okay.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.